examples, but we are going to use these four in all the problems today. So what do I do when I have a power to a power? The 6 multiply. So this is x to the 24. Good. Easy way to start. What about if I had a negative exponent? We're going to see negatives today. It kind of flips, right? Like if it's on the numerator, like here, that x to the 5th becomes positive and moves to the denominator. And then I have 1 over x to the 5th. What if in C, I have all the same base, but no power to a power? What do I do with the exponents? Add them. So what's 9 plus 2 plus negative 1? 10. 9 plus 2 is 11 minus 1 is 10. Okay, we're going to use that guy a lot. And finally, if I have a fraction, what do I do with our exponents? Subtract. So it'll be x to the 5th. Okay, good. I wanted those to be really easy. That we will use all 4 of those today. Now let's review what we did Friday because it's just nice to see it again before we get to more complicated problems. We solved exponential equations. So we said these were called exponential because they had exponents. And we used this method called common basis. So what is nice about number 1? What's the base of both exponentials? 5. So what do we do when we have the same base on both everything? Set the exponents equal to each other. So I can jump right to saying that 32 is equal to 16x. If the bases are the same, the exponents have to be the same. And then all I have to do is solve for x by here dividing by 16. So what is the value of x? 2. That is a super simple one. If I give you the same base, set the exponents equal. Now number 2, not a lot harder, but a little bit harder. I have to find a common base between 64 and 16. This is where that know your powers chart might come in handy. Do you see one of these guys here that uses 16 and 64? 4. Now, is there anything else you could use potentially other than 4? 2. Yes, 2 is 16, and then actually 2 to the 6th is 64. So you could use either 2 or 4. Do you think it matters? No. So which one do you want to use? 4. Okay. So let's rewrite the 64. What 4 to what power gives me 64? 4 to the 3rd. So I write 4 to the 3rd, and then I have to rewrite the power 2 to the x, 2x, on the outside. Then I do the same thing on the right. How do I rewrite 16 with a base of 4? 4 is squared. And then again, I rewrite that exponent, x plus 1. I'd like you to show all the steps for now because it'll get a little bit more complicated in a little bit, and you'll want a little bit more work shown. All right, now I can use one of my rules, that first exponent rule from the top of the page. Power to a power. What do I do with those exponents? Multiply. So I will get 4 to the 6x, 3 times 2x, equals, now the only tricky part over here is distributing 2 times x and 2 times 1. So what do you have on the right-hand side? 4 to the 2x plus 2. Then I have a common base, and I set my exponents equal. So I'll have 6x equals 2x plus 2. I move the 2x over, I get 4x equals 2, and what's your final answer when you divide? 1/2. Good? Not too hard? Alright, these are just the warm-up ones, so that's good. Number 3, what base do you think you're going to use between 3 and 81? 3. Okay, so the right-hand, or the left-hand side doesn't have to change. What did we do when I had a fraction? 3 to what power is 81? 3 to the 4th, but I have to make it negative because I'm in the denominator of a fraction. Right? So when I have a fraction, that's 3 to the negative power. And then I just set the exponents equal. 2x plus 2 equals negative 4. I'm going to subtract 2, which will give me 2x equals negative 6. So what is x? Negative 3. Okay. So the only exponent rules that we only use 2 different ones. We use the negative exponent, and we use power to a power. The next few examples will include more rules, all right? And just ones that we have to be careful about. All right, so the left side is 6 to the negative 2 times 6 to the negative x equals 1 over 216. What base do you think I'm going to use with 6 and 216? 6. Okay, so the left-hand side, I don't have to change. I'm just going to rewrite the left-hand side as it is. How do I rewrite 216 with a base of 6? Yeah, 6 to the negative third. Okay, so now we have to think, what exponent rule am I going to use? Well, what did we use? This is part C of the exponent rules here. What did I use? Yeah, I had to add them. I didn't have power to a power. I just had all the same base. So what I'm going to do is I'm going to add these exponents, not multiply. So what is negative 2x plus a negative x when I add those up? Because that's really what I have, 6 to that power. Negative 3x. Okay, so I'm going to rewrite that so it's a little cleaner looking. 6 to the negative 3x is 6 to the negative third. Then I set my exponents equal. And then what does x give me? 1. Okay. Now, how can I check these? These are easy to check. How do I do that? Yeah, so what I would do is take your calculator, type 6 to the negative 2 times 1 times 6 to the negative first, and see if you get 1 over 260. Okay. That's an easy one. Let's try another. 2 to the x times 1 over 32 equals 32. Okay. What base am I going to use between 2 and 32? 2. Okay, so 2 to the x stays the same. What is 1 over 32 with a base of 2? 2 to the negative fifth, right? And then what should it be on the right for 32? It's just 2 to the fifth. So just like the last one, I'm going to add these exponents because they have a common base. So what's my exponent on 2 going to be? What happens when I add x and negative 5? X minus 5 equals 2 to the fifth. All right, and then I set them equal. X minus 5 equals 5. And what does x equal? 10. Okay. First couple are very easy. All right, flip over. Got a couple more. So slowly get a little bit more challenging as we go. All right, 81 times 9 to the negative 2b minus 2 equals 27. What common base should I use for 81, 9, and 27? 3. Yeah, I see that on my Know Your Powers chart here. So, how do we write 81 with a base of 3? 3 to the 4th. Okay. 9 we know is 3 squared, but we need to make sure that we use the same exponent, negative 2b minus 2, outside of that 3 squared. Equals 27 is 3 to the 3rd. Okay, now before we can add the exponents, what do I have to do? Distribute, multiply here, the 2 times the negative 2b and negative 2, right? There's an intermediate step. So I still have 3 to the 4th, but what's the power on the second 3? 3 to the negative 4b minus 4. All right, now let's figure out when I have to, again, just like the last problem, add these exponents together. I'm going to have 4 plus negative 4b minus 4. What is that? Negative 4b. What happens with this 4 and the negative 4? They go away, so I really just have 3 to the negative 4b equals 3 to the 3rd. Are we okay with getting that? Yes.
9 to the negative 4b?
No. The base doesn't change.
3 times 3.
Nope. Think back to your exponent rules here. Very first one. Did I change the x's here? No. But the 3 isn't a coefficient. The 3 is a base. It's not 3x to a power. It's just 3 to a power. So, like if I have, for example, say I have 3 squared times 3 to the 3rd. That's really taking 3 times 3 times 3 times 3 times 3. How many 3's is that? 3 to the 5th, and there's 5 3's here, right? That's not a coefficient. All right, now all I have to do is set my exponents equal to each other. Negative 4b equals 3, and what's b? Negative 3/4. Okay. We good on that one? Halfway. Almost there, folks. Ooh, this one's different. Ooh, I have fraction, and I have an 8, a 4, a 1/28. What base should I use for 8, 4, and 1/28? 2, yeah, 1/28 is not on your know your powers chart, but that's 2 to what power? The 7th. So I'm going to use 2 as my base here. So how do I rewrite the 8? That would be 2 to the 3rd. Okay, and then I use my same exponent of 5x. Okay, over 4 is 2 squared to the 3x power. And then 1/28 we just said was 2 to the 7th. Okay. What do I have to do first on this one? Yeah, power to a power. So I have to multiply those exponents together. So you will get 2 to what power? 2 to the 15x over 2 to the 6x equals 2 to the 7th. Now, what did we say we do with these exponents when I have a fraction and the same base? Subtract them. So what is 15x minus 6x? 2 to the 9x. That equals 2 to the 7th. So now I just have the exponents equal. 9x equals 7, and divide by 9. So x is 7/9. So that was a little bit different. Last two. Does it seem easier today than Friday when we first saw it? No? Yes, kind of. Stick with me there. Promise. All right. I have a 1/6, a 2/16. What base do I use for 6 and 2/16? 6. Okay. So how do I rewrite 1 over 6 with an exponent of 6? 6 to the negative 1. Okay. So then I use my same exponent, 3x plus 2. What is 2/16 with a base of 6? 6 to the, you don't know, look at your power chart, 6 to the 3rd. So I have 6 to the 3rd here, and then I use the same exponent again, 3x. Equals 6 to the negative 3rd, yeah. Okay, so before we move on, just like the last couple, we do power to a power to start. So here for power to a power, I have to distribute the negative 1. So I have 6 to the negative 3x minus 2. Are we okay with that? Okay, what's the next guy when I multiply power to a power? 6 to the 9th equals 6 to the negative 3rd. And now we have all the same bases. So what do I have to do on the left before I can set things equal? I add them. So I have, oh, I lost my x here. Sorry. So I have negative 3x plus 9x. What's the exponent? What's negative 3x minus 2 plus 9x? Yeah, 6x minus 2. Equals 3. So then, at the same base, I set the exponents equal. So I add 2, and I get 6x equals negative 1, and divide by 6. Seeing the patterns a little bit, some of us, hopefully. The last one's different. This is 6 times 1/3 to the 2x plus 1 equals 54. What's the common base between 6, 3, and 54? Nothing, you're right. All right, I don't see 6, 3, and 54 on there. So this is still a common base problem, but I have to come up with another way to make it common bases. So think about it for a minute. Think about it. I have 6 times something. Can I maybe rewrite the right-hand side to be 6 times something? 6 times what? What is 6 times 1 is 54? 9. Does 9 have a common base with 1/3? What is it? 3. So this one, not everything has common base, but I can rewrite it and manipulate the problem. So let's redo this. We have 6 times 1/3 to the 2x plus 1 equals 6 times 9. Okay? And we said the 1/3 and the 9 have common bases. So how do I rewrite the 1/3 here with a common base of 3? Yep, 3 to the negative 1. Keep your same exponent. And how do I rewrite the 9? 3 squared. Wait, do you see where this is going now? What happens with those 6's? They do cancel, because if I divided both sides by 6, oh, they would go away. And then I have common bases. I have 3 to the negative first to the 2x plus 1 equals 3 squared. And I'm back to where I like to be. So all I have left to do is multiply these exponents together. So I'd have 3 to the negative 2x minus 1 equals 3 squared. Does that make sense now? It looked a little different, but now it's the same. So now I will take my negative 2x minus 1 equals 2. Plus 1, is it? No, it's not. Negative 1 times 1 is negative 1. Add 1. And x equals negative 3 over 2. Okay, we feeling a little bit more comfortable. Now we don't have a lot of practice problems. This one only has 4 practice problems. There is a video on Canvas if you need. I didn't leave you room to work though, so you'll need some scrap paper. I have scrap paper, you can use your own. The answers are right there. So I want you to try these. I know this is easier when I'm going through it, but there are a couple